You'll notice that the 4 inner planets are really tiny. The reason they're tiny is because they have either no atmosphere or very thin atmospheres. The 4 outer planets, the Jovian planets, have very thick atmospheres. These are the inner planets. Yeah. Mercury, Venus, Earth, and Mars. That shows their relative sizes. And they're the rocky planets, what are called the terrestrial planets. And the outer planets are called the Jovian planets. Inner planets are very small and rocky. Outer planets are very large and gaseous. This is a diagram that shows the relative sizes of all the planets. So you can see the interior planets are very small and rocky compared to the outer planets. And of course, Pluto's not a planet anymore, doggone it. It's just a satellite. I knew it was going to happen eventually. Had to happen. It was just too odd. The rocky surface of these planets is about this size of the Earth, embedded deep inside. The rest of that is just gas. But this is the order that they occur in. On the test, I want you to know this order. I want you to know the closest planet to the Sun is Mercury, next is Venus, next is Earth, and I will ask for this. So if you don't know it, you need to learn it really quick. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and then there's the Pluto, which has been demoted. Yeah, Michael?
What conditions cause for the Jovian planets to get such a large atmosphere?
Well, astronomers believe, according to the nebular hypothesis, that all of the planets had those massive atmospheres to begin with. But at some point in the development of the Sun, there was a tremendous burst of energy from the Sun, like a belch or a sneeze. Like if I sneezed really bad right now, Beetlein would be in big trouble, right? Because she's closest. And so she's going to get the force of the blast, much worse than Bond. Bond is far enough away. He's like Pluto or Jupiter, so he's far enough away that he's going to hardly feel my sneeze. See what I'm saying? And so because they're further away, there's going to be less energy. And so according to astronomers, these 4 inner planets were so close to the Sun that whenever it sneezed, whenever it belched, whatever it did, it blew away their atmosphere. And what atmospheres they have now is just what they were able to form since that event. Yeah. Whereas the outer planets, the Jovian planets, were far enough away that they were able to hang on to their atmospheres. That's all speculation, but that's the kind of speculation I have.
The Jovian planets, I forgot what I read, but have they detected a rock core?
Mm-hmm. Okay. Yeah, it's interesting that they've been able to do sonar investigation and magnetic investigations of them, where they can detect the general structure on the interior of them, and they're convinced that there is a rocky core about the size of the other planets. What's interesting, though, about the atmospheres of Jupiter and Saturn especially, is that they're so large that the pressure increases actually cause the gas. Their atmospheres are not just gaseous. They're gaseous on the outer edges, but the pressures actually force them into a liquid stage, and so you have liquid hydrogen. So it goes from gaseous hydrogen to an ocean, a liquid hydrogen. So there's an ocean of hydrogen below the surface, and eventually the pressures are so intense that it goes from a liquid phase into a solid phase, which for hydrogen is a metallic phase. And so if I threw you into Jupiter, you began to fall toward the center, you would be free falling through a gas, hydrogen gas, but eventually it would get thicker and thicker and thicker like a thick fog, and eventually it would become fluid, and you would enter into a liquid hydrogen ocean. And it would pull you, you'd go deeper and deeper in that hydrogen ocean. Eventually you get to the bottom of the hydrogen ocean, and you would be on metallic hydrogen. But it would still be hydrogen. And then deep inside of that metallic hydrogen would be a rocky core. So it's a little bit more complex than just seeing it all as atmosphere. All right. I've shown you this before, right? It looks like an exploding star, but what's happening is this isn't exploding. This is actually a, see if I show it again. You're looking at progressive stages of a beam of light coming from inside that star. So there's a pulse of energy. And this is similar to the type of thing they're talking about with our sun. It would be a pulse of energy or a belch or a sneeze that occurred that would blow away the atmosphere. So if you had planets here, it's possible that those planets could lose their atmospheres. Yeah, this just shows other stars that are emitting energy. See those jets? So the idea that our sun in its early stages emitted this pulse of energy It's not something that they're just making up. Stars do that different times.